So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamualaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So we were discussing section number 2 and we were going through section 2.1, the kinetic particle model of matter. Let's get on ahead and we'll start with pressure in gases. Molecules in a gas are in constant random motion at high speed. So random motion means that the molecules are traveling in no specific path and they undergo sudden changes in their motion whenever they collide with each other or whenever they collide with the walls of the container. Pressure in a gas is caused by those collisions with the surface of the container. As the gas particles move randomly, they collide with the walls of the container, causing a pressure on the container. They produce a net force. These collisions produce a net force at right angle to the wall of the gas container or whatever is the surface. Therefore, a gas at high pressure has more frequent collisions. If you increase the pressure of a gas, it would collide more rapidly. It would apply more force to the walls of the container. Hence, the higher the pressure, the higher the force exerted up per unit area. In order to test that the gas particles move randomly, we have a little experiment that is known as Brownian motion. It is the random and irregular motion of gas and liquid molecules. Basically, Brownian motion was discovered by a scientist named as Brownian, and his experiment is still a part of physics. And that random movement of gas or liquid particles inside their container is known as Brownian motion. It provides a clear evidence for the kinetic molecular model of matter in the fact that matter is comprised of tiny invisible particles which move around in a random manner. When small particles such as pollen or smoke are suspended in a liquid or gas, they can be observed through a microscope moving around in a random erratic fashion. Now, why do we add smoke or pollen grains? Because they are lightweight and they can be seen with a microscope, whereas you cannot use a normal microscope to see the molecules or atom themselves. Hence, we basically pour some larger particles such as smoke particles or pollen particles into a sea of tiny invisible particles that are the atoms or the molecules of a gas or a liquid, in order to know that how would they move. When observing Brownian motion, only the microscopic particles can be seen. The pollen or smoke are seen to move. Smaller atoms and molecules of water and air are too small to be seen. But when they move, they take these light particles of smoke or pollen with them. Hence, we are able to observe the motion. As the molecules of water, liquid or gas collide with the pollen or smoke particles, they make them move as well, or to change their speed. The presence of light, fast moving atoms and molecules is inferred from the motion of the microscopic particles. Now here is the piece of equipment that we need for the Brownian motion experiment. We need a microscope, we need a container with some air and smoke particles or pollen particles, and on top of that we place a glass slide, a transparent glass slide, and we always have a light source or lamp facing towards the glass container, and we have a microscope on top, and through the microscope's eyepiece we can see something like this, that is smoke particles move in at different speeds and at different directions. This is known as the Brownian motion. Example question, figure 3.1 represents the path taken in air by a smoke particle. The smoke particle can be seen through a microscope, but their air molecules cannot. State what causes the smoke particles to move like this. Smoke particles move like this because of collisions and movement of air molecules or any other gas or liquid particles or atoms that may be used for the experiment. What conclusion about air molecules can be drawn from this observation? We can draw, this is of 2-mark question, so we have to state 2 points. Air molecules are smaller than smoke particles, 1, and they move at a faster speed, having high kinetic energy, hence they move in random movement in all directions, not in just a specific direction. As you can see, the particles start from here and then it move in a random erratic behavior. Then we have something that links the pressure and volume of a gas at constant temperature. If the pressure or if the temperature of a gas remains constant, the pressure of the gas changes when it is compressed. If you try to compress a gas, then the pressure of the gas will go up. Means if the volume decreases, the pressure will go up. Expanded, if you increase the volume of a gas, if you uncompress a gas, if you expand a container, then the pressure of the gas will be lowered. Similarly, a change in pressure can cause a change in volume. When pressure is decreased, the volume of gas increases, keeping in mind that the temperature is kept constant. When a gas is compressed, the molecules will hit the walls more frequently, hence increasing the pressure, whereas when the container is expanded or the volume is increased, the gas molecules will collide with the container walls less often, decreasing the pressure. Pressure and temperature. Now if we are keeping the volume constant and we are dangling with pressure and temperature only, then the average speed of motion increases when the temperature increases. Since the average kinetic energy depends on the speed, the kinetic energy of molecules also increase if its volume remains constant. The hotter the gas, the higher the average kinetic energy. The cooler the gas, the lower the average kinetic energy and lower the speed of the molecules. As the gas heats up, the molecule will travel at a higher speed and they collide with the walls more often, increasing the pressure. Therefore, at a constant volume, an increase in temperature increases the pressure of a gas, and a decrease in temperature causes a decrease in pressure of a gas. That is why when we are filling gasoline, sorry, not gasoline, when we are when we have to fill CNG, compressed natural gas, into vehicles or cylinders, it is best that the gas is cooled. It is at a lower temperature in order to not put too much pressure on the CNG cylinder or the LPG cylinder, otherwise too much pressure can cause an explosion. That is why it is often written on walls of some of the filling stations that gas is available at a cold temperature. Since the temperature is proportional to pressure, the graph is always a straight line. Next, we have something that is known as the Boyle's law. The Boyle's law states that the pressure of a fixed amount of gas is inversely proportional to the volume of gas. Like the mass, it basically relates the pressure and volume together when the temperature is held constant. Keeping in mind, in order to apply Boyle's law and its equation, you have to make sure that the temperature is kept constant. So the Boyle's law states that P1 V1 is equals to P2 V2, means pressure 1 and volume 1 of a gas are always equal their product is always equal to the pressure on gas multiplied with the final volume. P1 and P2 are the initial and final pressure, whereas P2 and V2 are the final volume of a gas. We are keeping the temperature constant, and we are simply trying to work out one of these quantities using this equation. We usually apply this law or this equation when we are given an initial pressure and an initial volume, and then a third quantity as the final pressure or the final volume, and then we have to find the missing quantity. Any three of these four quantities would be given to you about any object, and you'll have to work out the fourth one by rearranging this equation. Just remember that pressure is in this equation, pressure is supposed to be in Pascal and volume is supposed to be in meter cube. So if it is given in centimeter cube, you'll have to convert it into meter cube. So here's a little animation. Let me play it out for you. And here's the animation. It shows that when you increase the pressure, when you decrease the volume, the pressure goes up, whereas the temperature is kept constant, and the graph of Boyle's law looks something like this. When you increase the pressure, when the pressure is increased, the volume is decreased, whereas the mass of the gas is kept constant and the temperature is constant. Basically the mass remains the same, whereas the temperature is also kept constant at 300 degrees, and when the force is applied, the volume is decreased, the pressure goes up, as seen by this graph as well. When the volume is decreased, the pressure goes up. Example question: a passenger in an aircraft closes a plastic bag with some air inside. When the bag is closed, the pressure of air inside the craft is 80 kPa, kilopascals, 80,000 pascals, and the bag contains 500 centimeter cube of air. When the aircraft is on the ground, the pressure of the air inside the craft is 100 kilopascal, 100,000 pascals. Calculate the volume of air inside the bag when the aircraft is on the ground. Now you are given the initial pressure and volume and the final pressure. You have to work out the final volume. So P1 V1 equals to P2 V2. Let's rearrange it. 80,000, we convert this kPa into Pascal. 80,000 multiplied by 500 divided by 1000, that would give us our volume 2. Now over here we have not converted the volume into meter cube, as 500 centimeter cube is a rather small volume, and we would simply state our you can say answer in centimeter cubes. In this question the answer was supposed to be given in centimeter cube, hence we have not converted it back. In the question paper the examiner has given the answer space, and along with it had already written the unit as centimeter cube. That is why we have not converted this 500 into meter cube. So we'll simply rearrange it. 80,000 multiplied by 500 divided by this P2, that is 100,000, and this gives us 400 centimeter cube. 400 centimeter cube would be the volume on Earth. When the pressure is increased, the volume decreases. State any two assumptions that you made in your calculation in B1. This is a 2-mark question. You have to state two assumptions. So the first one can be no air escaped from the bag during the landing. The temperature remained constant, although it is not mentioned in the question and we have no way of knowing that, but we have to assume it in order to apply the Boyle's law. Otherwise we have no other formula relating these quantities. And or you can also write that intermolecular forces between the air molecule is negligible. In Boyle's law we only talk about the pressure and force being applied on the walls of the container or walls of the plastic bag in this case, and we don't really consider the intermolecular forces between the air molecules or the gas molecules. So that's it for section 2.1. I hope you have understood everything. If you have any problem, feel free to contact me. Please do give your comments below and like, share and subscribe my channel. And I'll see you guys in the next video. Take care. Allah Hafiz.